Right, very good morning to all of you. The 14th question. In the given circuit, the sliding contact R is pulled outward such that electric current in the circuit changes at the rate of 8 ampere per second. That means the given rate of change of current in the circuit while pulled out the sliding contact. So what is that? 8 ampere per second. 8 ampere per second. At an instant when R is 12 ohm. Okay, at any instant when R resist in the circuit equal to what? 12 ohm, the value of current I is how much? Okay, whenever connected an inductor to a potential divider is due to self inductance and EMF is induced. Okay, therefore induced EMF in an inductor okay is L is equal to minus E by what is the di by dt. That implies E is equal to minus L into di by dt. Very well. Okay, right. This EMF is drawn from this battery. So resultant EMF is equal to what is that? 12 volt minus L into di by dt. Okay, from Ohm's law, this is V is equal to what? I into R. Okay, you want to calculate I. Therefore, I is equal to 12 minus L. L is already given. What is the inductance given in the circuit? Is there any? Is it there? L inductor already given 3 into the rate of change of current. What is that? 8. 3 into 8 by R. R is what? 12 ohm already given. So what is the given? Already, moreover, this is equal to what? Minus L. This is equal to what? Minus L. Why? Because induced EMF is always opposes the current induced inside it. The direction of induced EMF is always opposes the induced current inside it. So it is equal to what? Plus 4. So 12 plus 24 by 12. Okay. So the current is equal to what? 3 amp. So this is the solution for this question. Okay. Thank you. The 15th question. Refer to the circuit diagram given in the figure. Which of the following observation is correct? There are 5 observations are given. Okay, which of these observations are correct? That is asking the question. To see, while seeing this diagram, this is a battery of 6 volt which is connected to a 4 volt resistor. At junction D, there is a diode. Okay, across this diode, there are 2 resistors are connected in parallel. Okay, to see, current starts always from high potential, means positive end of this battery. So, say current C at same current is flowing through 4 ohm, while the current reaching at junction D, there is a 2 different ways. Okay, some current is passes through this diode, rest is passes through this one, isn't it? Now what happened? Again the current, what is the current passes through diode? Same current is passes through the resistor also. Okay, here at junction D, the current passing through it is reaches to this junction, same current is reaches to junction. These two are again combined and reaches to this is the battery. Okay, this is the way of current. Here to see, this diode is in what direction? This is positive, this is positive. So what happened? Diode is in forward bias, so it is allowed to current passing through it, isn't it? So need not to worry about that. That means you can replace this circuit. This diode may be, okay, replaced it. That means this is not required. This is a circuit diagram. Okay, now to see at this from this diagram, you know, this 4 ohm is in what? Parallel. So what is the resultant of parallel? Resultant of parallel resistance. What is that? Rp is equal to R1 R2 by R1 plus R2. Therefore Rp is equal to 4 into 4 by 4 plus 4, 16 by 8. That means what? 2 ohm. So I would like to replace this whole resistor by this thing. Sorry. This is what A. Okay, now this the circuit diagram is redrawn like this. What is that? This is 6 volt battery. What happened? This is the ammeter. This is the 4 ohm resistor. Okay, this is junction C. This is junction D. Okay, which is A. This is 4 ohm. Instead of this one, I would like to replace. What happened? This 2 is replaced by, okay, a resistance equal to what? Resultant 2 ohm. Now connected to this one. Okay, again what happened? This 4 and 2 are in series. That implies the circuit diagram is drawn like this again. This is an ammeter. Okay, this is what? 4 plus 2, 6 ohm resistor. In series, what is the resultant resistance? R1 plus R2. Okay, so this is the circuit diagram. Okay, therefore current in the circuit, I is equal to what? V by R. V is equal to what? 6 volt by resultant resistance in the entire circuit equal to what? 6 ohm. So what is the current? 1 amp. To see total resistance of the circuit is what? 6. Yes, this is correct. First option is obtained. Current in the ammeter, the same current is shown by the ammeter. What is that? 1 amp. This is also correct. Potential across AB is 4 volt. To see potential across AB. To see what is the current is passing in entire circuit? 1 amp. Isn't it? 1 amp. But at this junction, some current is, okay, this 1 amp current is distributed at junction D. Isn't it? So different currents are passes across these two. So potential difference across AB and CD remains the same, but current is distributed. Okay, right. Next, potential difference across CD. What is the potential difference across CD? V is equal to I into R. I into R means what? Current is 1, resistance is 4. So PD, potential difference across CD is equal to what? I into resistance. Current is equal to what? 1, resistance equal to 4. What is it? 4. Okay, volt. Yes, potential difference across CD is equal to what? 4 volt. But you see, potential difference across AB is not same. Why? Because same current is not flow across this one. Okay, why? Because 1 ampere current is passes through this 4 ohm resistor, but at junction D it is distributed. So that the current passing through 4 this and this is distributed, so that it is not correct. That means potential difference across AB is not correct. So VD, that means this C is not correct. Okay, the total resistance of the circuit is what? 8 ohm. It is also not correct. So from these given options, A, B and D are correct. A comma B and D are correct in this question. Okay, right. The 16th question, a positive ion A and negative ion B. This is a positive ion, this is a negative ion. Okay, has charges. So Q1, charge of positive ion, what is that? 6.67 into 10 power minus 19 coulomb. And Q2, this is what? This is Q1, this is Q2. Okay, right. Its charge is what? 9.6 into 10 power minus 10 coulomb. And their masses, mass of this positive ion M1 is given what? 19.2 into 10 power minus 27 kg, and mass of negative ion M2 is given. What is that? 9 into 10 power minus 27 kg respectively. At an instant, the ions are separated by a certain distance r. Okay, these two ions are separated by distance r. Okay, at that instant, the ratio of the magnitude of electrostatic force. So these two are what kind of charges? opposite charges. So this positive ion attracts, okay, this negative charge, that means pull towards its direction. Similarly, at the same time, this negative charge experiences force on this positive charge and pull towards its direction. So what kind of force is existing between them? Okay, electrostatic attractive force. So from electrostatic force, okay, existing, which is obtained by Coulomb's inverse scalar, Fe is equal to what? 9 into 10 power 9 into Q1 Q2 by R square. Similarly, these two are certain mass, so gravitational attractive force existing between them. So the magnitude of gravitational force of attraction, what is that? 6.67 into 10 power minus 11 into m1 m2 by r square. What is asking? The ratio of magnitudes of electrostatic force and gravitational force. Therefore, Fe by Fg is equal to 9 into 10 power 9 into Q1. What is the charge of the first one? 6.67 into 10 power minus 11 into Q2. Q2 is equal to what? 9.6 into 10 power minus 10 by, okay, R square by Fg, gravitational force. What is that? 6.67 into 10 power minus 11 into masses. First one, 19.2 into 10 power minus 27 into m2, 9 into 10 power minus 27 by r square. This r square, this r square is cancelled. Moreover, this 6.7, this 6.7 is cancelled. Okay, this 9 is also cancelled. Then remaining 19.6, okay, 2 times is 19.2. 9.6 by into 2 is equal to 19.6. So finally you get 1 by 2 into, while doing 10 power 9, 10 power minus 10, 10 power minus 20. While going to the numerator, this is plus, this is plus, this is also plus. But you get 10 power 45. This is the answer. Okay, but in the given question, P into 10 power minus 13 resultant magnitude of the ratio of forces. So this question is mistaked, okay, in while giving this question. So in this examination, this question is given a bonus for all the students. So this is the actual answer for this question, but this is a bonus marks given to all students while attending in this first session. Okay. The 17th question regarding self-inductance. Okay, some options are given. From these options you can select which of satisfies, okay, self-inductance. Okay, right. The question, what is it regarding self-inductance? You know what is self-inductance? Self-inductance. In any coil, due to change in magnetic flux, what happens? An EMF is induced, which is opposes the cause of inducing that current, isn't it? So from definition of self-inductance, L is equal to mu naught n square into A by 2 pi r. You know very well. Self-inductance formula, it deduced mu naught into n square into A by 2 into pi into r. To see here, mu naught is the, okay, permeability of the medium. Okay, here n is equal to number of turns in the coil. Number of turns in the coil itself. In the coil. Okay, A is equal to what? Cross section area of the coil. Cross section area of the coil. Okay, R is equal to what? Radius. That means perpendicular distance where you want to calculate the, okay, magnetic field inductance. Okay, R is the perpendicular distance. That means what? Radius of the coil. Radius of the coil itself. Okay, to see from this you come to a conclusion. Okay, based on this one you can select the correct option. The self-inductance of the coil depends on its geometry. Yes, obviously. Why? Because the self-inductance of a coil is depends on its cross-section area, its radius and number of turns. So option A is correct. self-inductance does not depend on the permeability of the medium. To see in the self-inductance formula itself, mu naught is the permeability of the medium. That means medium changes. Okay, all mediums are not equally allow to induce, that means experiencing or producing magnetic lines of forces up to some extent. So it is not correct. So self-inductance depends on permeability. Next, third option, self-inductance opposes any change in the current in a circuit. Actually, self-induced EMF is causes change in the current. Okay, it is opposes. When self-inductance is generated in a coil due to change in flux, whenever flux changes, EMF is induced. This causes induced current is generated. So when flux are not changes, there is no scope for inducing the current. So it is also correct option. Self-induced inductance is electromagnetic analogous of mass in mechanics. Yes, it is acts like that only. Okay, right. Next, option E. Work needs to be done against self-induced EMF is establishing in the circuit. Okay, it is correct. When you are doing a mechanical, it means due to change in magnetic flux that is done by the coil itself. So it may doing some work. Then only EMF is established inside it. Okay, right. So option E is correct. So from the given options, A, C, D, and E are correct. Okay, for this question, right. The 18th question. A subatomic particle of mass 10 power minus 30 kg is moving with the velocity v is equal to 2.21 into 10 power 6 meter per second under matter wave consideration. Okay, according to matter wave consideration. What is this? According to matter wave consideration, it is associated with a certain wavelength. Lambda is equal to what? H by P from de Broglie hypothesis. According to de Broglie hypothesis, every particle is associated with some wavelength. Why? Because it once act as a particle, it once act as a wave. So this is called dual nature of a matter. Matter is nothing but radiation. Radiation is nothing but a matter. When matter exhibits dual nature, radiation is also exhibit dual nature. That means once it acts as a particle, once it acts as a wave. So the wavelength associated with this subatomic particle is given by this equation. Lambda is equal to what? H by P. Here H is the Planck's constant. Therefore, what is the wavelength of this subatomic particle associated with a wave? H is equal to Planck's constant 6.63 into 10 power minus 34 by P. P is equal to what? Mass into velocity. That implies lambda is equal to 6.63 into 10 power minus 34 by mass. What is the mass? 10 power minus 30 into what is the speed? 2.21 into 10 power 6. Isn't it? This one 3 times is cancelled. So 1 by 3 into minus 10, that means minus 4 minus 6 minus 4 minus 6 with 10 power minus 10 meter. So wavelength of this subatomic particle is obtained 10 power minus 10 meter. Okay, actually this is belongs to which range? That means it is in the infrared region or X-ray region or gamma ray region or invisible ray region. According to electromagnetic spectrum, the wavelength from 10 power 14, what is the 10 power 14 to 10 power 11? Okay, that kind of that kind of ray is called gamma rays. These are gamma rays. Okay, if suppose the wavelength is lies between 10 power 10 to 10 power 10 to 10 power 7, 10 power 10 to 10 power 6 approximately, these are called X-rays. What is that? X-rays. Okay, if suppose the wavelength range is from 10 power 5 to the 10 power 5 to 10 power 5 to 10 power 6, 10 power approximately 10 power 7, that is called ultraviolet region. That means these are minus, these are minus. So this is comes under what? This thing. So the given subatomic particle wavelength falls under what kind of region? From this one, you can say what kind of region it is? X-ray region. What is that? X-rays. Okay, right. To the 19th question. A spherical surface of radius of curvature R separates air from glass. Suppose to see. This is a spherical surface. Okay, which separates air from glass. This is air. This is what I say, glass. Okay, already given its refractive index mu is equal to how much? 1.5. This is air. Its refractive index is equal to what? 1. Okay, the center of curvature is in the glass medium. So the center of curvature is in the glass medium. Okay, right. A point object O placed in air on the optic axis. Suppose what in the optic axis? The line which is passes through the center of the lens is called its optic axis. So on its optic axis, at some distance, a point object O is placed. Okay, so that real image is formed at I. So what happened? Some light rays are incident. Okay, they are got refracted. So image is formed inside the glass, already given. This is the glass medium. Inside this glass medium, image is supposed to be formed. Okay, the line OI intersect while you are joining object to image. Okay, which is intersect, the line OI intersect the spherical surface at P. Okay, so what is happening? PO given, PO is equal to PI. So the distance P2O is equal to P2I. Okay, the distance PO is equal to, this is supposed to be asking. Okay, you know very well, according to the Gauss relation for a single spherical refracting surface from Gaussian, what is it? From Gaussian relation for a single refracting surface. What it is? Gaussian relation. It is nothing but relation between object distance, image distance, and its radius of curvature. Okay, to see from this one, you know, P2O. Actually, the light rays are coming from object. Okay, incident on this refracting surface. Get what happened? Refracted and okay, what happened? Refracted and intersect at some point, that is called image position. So in this case, the light rays are coming from object, but you know the object distance is measured from pole according to sign convention, isn't it? So that PO is nothing but object distance, which is equal to what? Minus U. Okay, you don't need this value. It is nothing but what I say, X. So minus X. Okay, similarly PI, the light rays, that means the distance of image measured from same pole of this lens, point P, it is in the direction of incident light, so it is nothing but what I say, positive. So PI is equal to what? Plus V is equal to what? Plus X. You don't know its value. I would like to say suppose. Okay, but given what is that? PO is equal to what? PI. PO is equal to what? PI. So you know, object, suppose this is U1, this is called U2. Okay, you know one thing, object is in air medium. Object is in what? Air medium. Okay, image is at glass medium. So you can write mu2 by V minus mu1 by U is equal to, what is it? 1 by what is that? Mu2 by V minus mu, what is that? Mu2 minus mu1 by R. Mu2 minus mu1 by R. This is the relation is called what I say, Gaussian relation for single refracting surface. So you can substitute all this value. Therefore, mu2 by X, isn't it? Why? Because V is equal to what? X minus mu1 by U is equal to what? Minus X is equal to mu2 minus mu1 by, what is that? That implies mu2, refractive index of glass medium, what is that? 1.5 by X minus mu1 is equal to air. For air, refractive index is equal to what? 1 always. 1 by plus X. That means this minus plus 1 by X is equal to 1.5 minus 1, okay, by R. That implies you can take x is the LCM. Here 2.5 is equal to what? 2.5 is equal to what? 0.5 by r, isn't it? 5 1 ja, 5 5 ja. That means x is equal to what? 10. Okay, x is equal to what? 5. That is, this is r here, not 2. That implies x is equal to what? 5r. This is the answer for this question. Okay, right. The 28th question, identify the valid statements relevant to the given circuit at the instant when the key is closed. So this is the circuit diagram. In the circuit diagram, positive terminal of a battery connected to a resistor through plug key K. Okay, and another end is connected to one of the plate of a parallel plate capacitor, and second end is connected to the negative terminal of the battery. So when you close the key, what is happening? To see what is that? First one, there will be no current through the resistor. No, it is not correct. Why? Because according to theory, whenever you connect it to the battery to a resistor, there is a maximum safe current is allowed to passing through it, isn't it? So there will be no current on the resistor. Is it wrong? Okay, next one, there will be maximum current in the connecting wires. Yes, why? Because there is only one path for flow of current. There is no distribution. So what happened? Okay, there will be maximum current in the connecting wires. Yes, it is correct. Next one is potential difference between the capacitor plates A and B is minimum. Yes, it is correct. Why? Because potential difference, you know, what is the basic principle of a charging a capacitor? While charging a capacitor, what happened? Some charges accumulate, okay, without altering its potential. That's why you can arrange two parallel plates separated some very little distance. Okay, so potential difference between the capacitor plates A and B is what? Minimum. Yes, it is also correct. Okay, next, charge on the capacitor plates is minimum. Yes, it is also correct. Why? Because air is a dielectric medium. Okay, whenever you can introducing any other dielectric medium of dielectric constant K, its capacitance is increased by K times by increase the charge stored inside it. Okay, so from this one you can select what is that? B, C, D are correct. Okay, right. The 21st question, what is the lateral shift of a ray refracted through a parallel sided glass slab of thickness h in terms of angle of incidence and angle of refraction if the glass slab is placed in air medium? To see, this is a parallel, okay, this is a parallel sided glass slab. This is a parallel sided glass slab of thickness h. Of thickness is what? H. Okay, when it is placed in air. So this is what? Air medium. This is what? Glass medium. Okay, so due to my facility, I would like to draw a normal to this parallel side. So this is called, say, called M. What I can say, a light ray is incident obliquely. A light ray obliquely incident at point O, okay, of the interface of this air glass medium. Okay, what happened? Whenever the glass slab is not appeared here, it is traveled like this, isn't it? It passes like this. So this is called angle of incident I. Okay, at this point, you can say this is also equal to what? Angle of incidence I, when you draw a normal to this one. Okay, right. Now what happened? Due to glass slab is presence, what happened? The light ray is traveling from rarer medium to denser, it bend towards the normal due to suffering velocity. So what happened? The light ray is what? Get refracted. This is what I say, R. This is what? This is I, this is R, then this is equal to what? I minus R. I minus R. So it is intersect at some point, okay, on this a glass air interface. So then what happened? Again it travel from denser medium to rarer. It is bent away from the normal. So this light ray is called emergent light ray. This is what I say, emergent. You know, this is the perpendicular distance between actual path and refracted path is called lateral shift. Is called, say, called X. This is called what I say, lateral shift. So this is point O, this is point P, this is point say called Q, say for example, sake of our convenience. He is asking X may be expressed in terms of angle of incidence and angle of refraction. He is supposed to be asking. Okay, so in this diagram OPQ, you may write, you want to calculate, this is what, 90, isn't it? This is what, 90. Okay, this is right angle triangle. So you want to calculate sine I by R is equal to sine I minus R is equal to opposite by hypotenuse. What is that? X by hypotenuse is equal to what? OP. We don't know its value. That implies X is equal to what? OP into sine I minus R. So you know OP, then you can easily write the required thing. What is that? Lateral shift in terms of angle of incidence and angle of refraction. So to getting this OP value, you can use this another right angle triangle. What is it? OMP. From OMP, I would like to write, this is what hypotenuse. So this is, no, what is that? This is the thickness of the glass slab. So I could write cos R. Cos R is equal to, okay, cos R is equal to what? Adjacent side. What is that? OM by hypotenuse OP. But you know, OM is what? Thickness of the glass slab, which is equal to what? H. So it may write H by OP. H by OP. That implies OP is equal to what? H by OM by OP. That implies OP is equal to what? H by cos R. Isn't it? H by cos R. So this is equation 2. This is equation 1. From 1 and 2. From equations 1 and 2. That means you can replace OP in this equation by this thing, then you get the X value. That is called the lateral shift or lateral displacement. X is equal to, OP is equal to what? H by cos R, H by cos R into sine I minus R. Therefore X by H into sine I minus R by cos R. So you get the lateral displacement in terms of angle of incidence and angle of refraction, isn't it? So this is the, okay, this is the answer for this question. Okay, right. The 22nd question, a radioactive nuclei N2 has 3 times the decay constant as compared to the decay constant of another radioactive nuclei N1. If the initial number of both nuclei are the same, what is the ratio of number of nuclei of N2 to the number of nuclei of N1 after 1 half life of N1? Okay, this is the question asked. Okay, solution is like this. To see, we all of you know, according to law of radioactive decay law, that means according to law of radioactive decay, the number of nuclei present at any instant, okay, n is equal to n0 into e power minus lambda t. Okay, here there are 2 radioactive nuclei are given. This is the first radioactive nuclei of radioactive nucleons is N1. This is the N2. This is another second radioactive nuclei. Okay, its number of nuclei at any instant is called N1. Okay, its decay constant is called lambda 1. Okay, its decay constant lambda 2 is equal to what? 3 times. That means 3 times the decay constant of compared to the decay constant of another radioactive nuclei N1. Okay, initially both are having same number of radioactive nuclei. That means initially the number of radioactive nuclei are present in the given sample. N0 is equal to what? N0 is equal to what? N0. This is the condition. So what is asking after some time, means what is it? After 1 life period, what is the ratio of radioactive nuclei are present? That means N2 by N1 is equal to what? This is supposed to be asking in this question. Okay, from decay constant, what radioactive decay law? What is that? The number of radioactive nuclei present after 1 half life period. That means n2 is equal to, what is that? n0 into e power minus 3 lambda t. Similarly, n1 is equal to n0 into e power minus lambda t. Okay, now we can say n2 by n1. You can do n2 by n1. Therefore, n2 by n1, what happened? n0 is cancelled. Therefore, n2 by n1 is equal to e power minus 3 lambda t plus lambda t, which is equal to e power minus 2 lambda t. Isn't it? Minus 3 lambda plus this minus lambda go to the numerator. It is nothing but plus lambda t. So, finally, n2 by n1 is equal to e power minus 2 lambda t is obtained. Okay, so t, that means half-life period. That means 1 half-life period of n1. Okay, is equal to, what is that? You know very well, log 2 by lambda. Isn't it? This is the constant. That means the first one, 1n. That means first life, 1n. Okay. After 1 life means what? n1 is equal to what? n0 by 2. After 1 life period, okay, n0 by 2 number of nuclear disintegrate. Okay, so which is equal to what? n0 into e power minus lambda t. Isn't it? Okay, right. That implies compared on both sides. This is cancelled. That implies t. That is what? T. Lambda t is equal to what? Log 2. Okay. Therefore, t is equal to log 2 by lambda. Isn't it? Log 2 by lambda, which is equal to log 2 is equal to get lambda t. But lambda t is nothing but what I say. Here t is equal to what? From this one t is equal to log 2 by lambda, which is equal to e power minus 2 lambda into log 2 by lambda. Isn't it? In place of t. In place of t. Okay, what is given? Log 2 by lambda. Okay, therefore n2 by n1 is equal to, what is that? 1 by 4. Why? Because log 2 is cancelled. Lambda is cancelled. Log 2 is equal to 1 by, after 1 life period, 1 by 4. Okay, right. That's it. So this is the answer for this question. Right. Right. The 23rd question. The electric field of an electromagnetic wave in free space. This is given. The associated magnetic field in Tesla. You know very well, if electric and magnetic fields oscillate sinusoidally, what is that? If electric and magnetic fields oscillate sinusoidally in space and time, okay, in an electromagnetic wave, okay, and electric field is along positive x-axis, magnetic field is along positive y-axis. So electromagnetic wave is represented by, you know, electromagnetic wave is represented by okay, E bar is equal to Ex I cap, isn't it? Ex I cap, which is equal to what? E naught sine omega t minus kx, isn't it? Or kz, whatever may be it, as per your convenience. Kz minus omega t. Kz minus omega t in x-axis, positive. That means, similarly, b bar is equal to by j cap. That means b naught into sine kz minus omega t into what? J cap. Okay, here given, what is that? Given k bar is this one. What is that? 4 I cap minus 3 j cap. Okay, now you may write its unit vector. What is that? K cap is equal to what? K bar by mod k bar. K bar is equal to what? 4 I cap minus 3 j cap by mod k means what? 4 square plus minus 3 whole square, which is equal to 4 I cap minus 3 j cap by 4 is 16 plus 9 equal to 25. 25 root over means what? 5. Okay, therefore, what you know? B cap is equal to what? K cap into electric field vector. Okay, from b cap by e cap is equal to what? K cap. Okay, moreover, therefore b is equal to what? Minus z cap. Okay, therefore b naught is equal to what? E naught by c, because b naught equal to what? C. Okay, so that E naught is nothing but what is it? Maximum value 57 by C is equal to what? 3 into 10 power 8. 3 into what? 10 power 8. Therefore, B naught, that means B, that means what is asking? The associated magnetic field vector B bar is equal to, what is that? 57 minus 57 by 3 into 10 power 8 into cos 3 into 10 power 7 into, is it 10 power 7 into 10 power 7 or 8, 10 power 8 into, okay, cos, what is the cos value? This thing 7.5 into 10 power 60, isn't it? 7.5 into 10 power 60, 7.5 into 10 power 60 minus, okay, B is equal to naught cos zt minus kx. Similarly, B bar is equal to B naught cos kz minus omega t. Okay, so B bar is equal to minus 57 by 3 to 10 power 8 into cos 7.5 into 10 power 60. Okay, minus, isn't it? Minus 5 into 10 power minus 3 into, okay, 3x plus 4y, same 3x plus 4y. Okay, this is in this brackets into, what is the value we get? What is it? K vector. What is the K vector is get? 5k. What is it? Where it is? Yes, 5k. 5k. Okay, so this is the answer for this question. Okay, right. The 24th question. Given a thin convex lens, its refractive index is mu2. Kept in a liquid, its refractive index is mu1. This mu1 is less than mu2. Okay, having radii of curvatures r1 and r2. Its second surface is silvered polished. Where should be an object be placed on the optics axis so that a real and inverted image is formed at the same place? Okay, to see this question. What is given? Given a thin convex lens. This is a thin convex lens. Okay, you know, on this thin convex lens, okay, okay, suppose an object is placed in front of it. This is an object. Okay, so what happened? A light ray is passes traveling from object and incident on this thin convex lens. So what happened? It is a refractive. Okay, moreover, if it is silvered at its second end, where should be the image is formed? Okay, first of all, actually, this is a lens, isn't it? This is a principal axis. This is a thin convex lens. Okay, on its principal axis, okay, an object is supposed to be kept. An object is supposed to be kept at here. Object. So what happened? This is the instant light ray, instant on this refracting surface, and form an image at I1, isn't it? Form an image at I1. Okay, but its second surface is what? Silver. So what happened if its second surface is silver? If its second surface is silver, okay, so this is reflected back. Object is same. What happened? Object is what? Same. But second surface is silver, it's reflected back and forms its image at I2. Forms its image at where? I2. Okay, but actually it is, okay, formed image. Generally it is formed at image at I1. Okay, later this is the image is act as virtual object for this mirror. Why? Because second surface becomes what? Silver. It acts as a mirror. Okay, so that, okay, it's a final image. This is the lens. Okay, this is the object. Okay, So this is the object I2. Okay, the light rays are instant on it, and final image formed at I3. Final image formed at where? I3. Okay, its radius of curvature is R1. Its radius of curvature is equal to what? R2. This is R1, this is R2, this is R1, this is what? R2, this is R1, this is what? R2. Both are different by convex lines. Okay, right. So what is the power? P is equal to, okay, power of lens. What is that? Power of lens. Next, power of mirror, isn't it? Power of mirror plus again power of lens. You know very well, effective power is equal to, what is that? PL plus PL, 2PL. 2PL plus PL. That implies, but you want to calculate its focal length, 1 by FE is equal to 2 by FL plus 1 by FL. 1 by FL. Using this formula, you can calculate the required answer for this question. Okay, now we can do it. Okay, right. We can write 1 by FE is equal to 2 into mu2 minus mu1 by mu1, 2 into mu2 minus mu1 by mu1 into R1 plus R2 by R1 plus R1 R2, R1 R2, okay, plus 2 by R2, 2 by R2. From this one I would like 2 by R2 is taken as common. 2 by R2 while taken as common, you can write mu2 minus mu1 into R1 plus R2 by mu1 into R1 R2. R2 is taken as common, so it is come out. So mu1 into what? Mu1 into R1. Okay. Therefore 2 by R2 into mu2 R1 plus mu2 R2 minus mu1 R1 minus mu1 R2 after simplifying it. mu1 into what? R1. Okay, is there any cancel mu2 R1? There is no chart. mu2 R2, there is no term. mu1 R1 minus mu1 R2. Okay, isn't it or not? Plus mu2 R2, that means 1 by, that means plus mu1 R1 is also there. Plus mu1 R1. So here to see mu1 minus mu1 plus mu1 is cancelled. Therefore remaining, therefore 2 by R2 into 2 by R2 into, that means you can check 2 by R2, mu2 R1, mu2 R2, mu1 R2. From this one I would like to take R2 taken as common, mu1 minus mu2 minus mu1. So 1 by F equivalent is equal to 2 by R2 into 2 by R2 into mu2 R1, mu2 R1, isn't it? mu2 R1, okay, plus mu2 R2 plus mu2 R2, okay, minus mu1 R1 minus mu1 R2 by mu1 R1 by mu1 into R1. Okay, from what is given, from same size of image is formed. For same size of image, you can write U is equal to what? 2F, isn't it? U is equal to what? 2F. Okay, therefore U is equal to 2 into Fe. 2 into Fe means what? R2 mu1 R1 by 2 into mu2 R1 plus mu2 R2 minus mu1 R2. This to this is cancelled. Therefore mu is equal to mu1 R1 R2 by mu2 R1 plus mu2 R2 minus mu1 R2. Okay, This is the answer for this question. This is u, sorry, u, not u. U is equal to u. That's why u is equal to this. Okay, right.